Assalamualaikum everyone. Welcome to Mathematics with Shahab Yaqub. We are on lecture number 19 of Algebra and it's about sketching curves, which takes time because it is very conceptual. Believe me that this concept of O-level maths, which they have expanded a bit more in the new syllabus 2025-2027, this will be really helpful when you'll be doing P1 and P3 in A-level math. So today I was talking to my class and we were discussing that what they have done in O-level maths, that is much better. They have added all these things which is new in O-level maths so that life becomes very easy in A-level maths. So now the agenda for today is reciprocal and then some past paper questions. For reciprocal, it's of this format: y is equals to m over x plus n, where m and n are integers. Functions will be equivalent to this form. So y is equals to k over x. Actually, there are two functions of this type. There is the reciprocal square and there is the simple reciprocal. So when we talk about this thing, it basically means y is inversely proportional to x. That means if x increases, y decreases. Or if x decreases, y increases. That's the meaning of inverse proportionality. Now, when we draw this graph, and one more thing, that is when x is positive, y is positive, provided we are taking k to be a positive constant. So if k is a positive constant, what is happening? If x is positive, y is positive. If x is negative, y is negative. Again, we have studied this when we got started with the reciprocal sketches, and now it's a bit of transformation of that. Now, if I draw this graph right away over here, so let me grab the grid that's over here. So the graph is somewhat like this. So let me grab a marker, and over here, the graph is in the first quadrant, and the graph is in the fourth quadrant like this. And let me just shift this graph up a little bit. I think it's okay. This is y, this is x. X increases, y decreases. When x is positive, y is positive. When x is negative, y is negative. So therefore, it's in the first and the third quadrant. This is the first quadrant, and this is the third quadrant. Now, the thing that we need to focus is on this blue line right over here. So let me make it thicker. So let me label this as the green line. That is the x-axis. Equation of x-axis is y is equals to 0. And this blue line over here, and that is y-axis, which is x is equals to 0. So now this graph over here, I'll just pause for Azan. So now the graph is drawn in the first quadrant and in the third quadrant. And these are the asymptotes. So this y is equals to 0. This is the horizontal asymptote. ASYMPTOTE, that's the horizontal asymptote, and x is equals to 0, that is the vertical asymptote. So it's a single S. Now what else is there? The graph does not pass through the origin, because if x is 0, any number divided by 0 is undefined. So k over 0 is undefined. Similarly, if y is 0, so k over x is 0, x is k over 0. This is also undefined. It does not pass through the origin. So now if I want to draw the graph of y is equals to 1 over x plus 1, what will happen? First of all, the horizontal asymptote will be shifted. Horizontal asymptote will also be shifted, and When will it shift or how will it shift? It will translate vertically up by 1 unit. That means now if I want to draw this graph, so let me use a green line over here. Let me make it thicker. So therefore the graph is, this is too thick. That's the line y is equals to 1. That's for this. And then we will draw 1 over x just like this. So k could be any positive constant. So let me draw this thing. So therefore I'm choosing this, and with respect to this we draw this, something like this. Okay. And with respect to this, that's how we draw it. So the horizontal asymptote is now y is equals to 1. HA represents horizontal asymptote. And VA represents vertical asymptote. So y-axis, which is x is equals to 0, that is the vertical asymptote, y is equals to 1, that is the horizontal asymptote. That's how the graph is drawn. What if I'm interested in drawing y is equals to 5 over x minus 3? Which might also have been written y is equals to 5 minus 3x over x. If I simplify it, this is 5 over x minus 3x over x, which is 5 over x minus 3. It's the same thing as this. So now the horizontal asymptote is y is equals to negative 3. So let me just shift this thing a little bit up. Let me draw the line y is equals to negative 3 like this. So this is y is equals to negative 3. That's the horizontal asymptote. Vertical asymptote is x is equals to 0. And now the graph will be drawn like this. So let me choose this purple color. And the graph goes like this, something like this, and something like this. So basically it's the same graph which is right over here, and since the asymptote is shifted, the graph is drawn with respect to the asymptote. Now if this is all good, all clear, just acknowledge it on the WhatsApp that all good, all clear. So this is the first worked example, y is equals to x plus 1. The second worked example, y is equals to 5 over x minus 3. Now some people, they ask this question, what about this 5? This 5 will increase the steepness, but it won't change anything. So it will simply increase the steepness, but it cannot be reflected on the sketch. It cannot be reflected or shown on the sketch. So it doesn't make a difference at all. So that's how this graph is drawn. Now, first of all, let me just take this grid and let me draw the graph. So hold for a second, I've copied it. Let me add a page over here. And over here, let me draw the graph of y is equals to k over x with a negative sign. Y is equals to negative k over x. K is a positive constant, but because of this negative sign, what happens? If x is positive, y is negative. If x is negative, y is positive. It's still inversely proportional. It is inversely proportional as before, x increases, y decreases. But what happens? We know that because of the negative sign, this is reflection in x-axis. That means if I look at this original graph, which is right over here, what will happen is that this thing will be reflected in the x-axis, this thing will be reflected up there. So over here, let me draw the original thing for any positive constant. Let me draw this thing in blue color. So let me choose the blue color from here. And the graph goes something like this. The graph goes something like this. The asymptotes are still the same. So over here, we have this blue asymptote. And we have this green asymptote. The horizontal asymptote, the vertical asymptote. This is y is equals to 0, horizontal asymptote, x is equals to 0, vertical asymptote, and that's how the graph is drawn. Now let's transform a graph of this type. What about y is equals to minus 3 over x plus 2? So now it's the horizontal asymptote that gets shifted. So horizontal asymptote is now y is equals to 2. So let me just draw this line, y is equals to 2. And with respect to this, we'll be drawing the graph. So let me just shift this thing a little bit up. And which color am I using? I'm using the blue color. And the graph goes like this, and the graph goes like this. So that's the graph of negative 3 over x. That is just like this, negative k over x. And the horizontal asymptote is shifted up by 3 units. So let me write y is equals to 3, that is the horizontal asymptote, x is equals to 0, that is the vertical asymptote. And let me draw another graph. Y is equals to minus 5 I've already used, let me use 4 over x minus 1. So now the new horizontal asymptote y is equals to negative 1 is the horizontal asymptote. It has been translated. So therefore, this was shifted 1 unit, 3 units up. Now we are shifting it 1 unit down. Let me just grab this thing properly. Okay. And over here, black color, over here, green color. And let me just erase this thing partially. So therefore, this is y-axis. This is x is equals to 0. That is the vertical asymptote. This is x-axis. But now, this thing over here, y is equals to negative 1. That is the horizontal asymptote. And we will draw it with respect to the horizontal asymptote. So therefore, this goes like this. This goes like this. So that's how the graph is drawn. So that is the transformation that is of that type, which is written over here on the main page. So now it's a good idea that we go over all the 4 lectures that are on the single PDF. So just let me know. I hope there is no lacking. 5 is not clear. What is meant by an asymptote? Thank you for asking that question. When we use the terminology asymptote, it means a line which the graph approaches but does not actually touch it. Now, if someone has just joined it, it's their responsibility to go over the notes, to go over the lectures, and go over everything. Now, let me first make you go through everything so that you have a pretty good idea what are we talking about. So let me open up 1 or 2 more PDFs. So that is 14, 15, and that's 12, 13. Okay, so now let's have a look at this. We got started with lecture 12. We talked about sketch, rough but realistic. We talked about graph, which is exact. And then sketch can be drawn anywhere, piece of paper, glass, surface, whiteboard, whatever. A graph paper is needed, a grid is needed, a table of values is needed. A basic idea is needed, whether it's about the slope or the turning point, y-intercept, x-intercept, shape. It could also be asymptote. And then we talked about linear graphs. This is lecture number 12. Possible equations, flat line, vertical line, quadratic, by plotting. The sketch idea, positive x squared, that's the shape, negative x squared, that is the shape, and we'll be doing some past paper questions now. Cubic curve, negative x cube, power graphs. One more thing that I can write over here, when y is equals to x cube, it starts from top right, goes till bottom left. Y is equals to negative x cube, it's a reflection of this. This starts from top left, goes till bottom right. Exponential graph that goes like this. It gets very close to the x-axis but does not actually touch it. Power graph, a raised to power of negative x. This is the story of decay. In lecture 13, we talked about simple reciprocal function. Y is inversely proportional to x. First quadrant, second quadrant, third quadrant, fourth quadrant. It is made over here and over here. K is any positive constant. No x-intercept, no y-intercept. And I did not talk about asymptote at this point. Y is equals to minus k over x, reflection in x-axis. Blue goes down and purple goes up. Square reciprocal, y is equals to k over x squared, y is inversely proportional to square of x. X is positive, y is positive. X is negative, square of x is still positive. And then we talked about past paper questions, understanding which graph looks like which, a perfect question. Some transformation related to reflection, translation, stretch. How do you draw 2x square? How do you draw half x square? Again, some graphs. So that is 12 and 13. So this is like lecture 13 that was done. Then after this, if we talk about 14 and 15. So 14. Then it's about construction and all these things and analysis of this quadratic curve. How do we plot it? Cubic curve, simple reciprocal. We talked about the concept of asymptote over here. It gets very close to this line but does not actually touch it. Now someone can ask this question that over here, when x is 0, this is the vertical asymptote. When x is 0, 2 over 0 is undefined. Any number divided by 0 is undefined. You cannot divide a number into 0 parts. That's simply not possible. No one has defined it as yet. Square reciprocal. This we skipped, this particular one. Some past paper questions, drawing tangent, answering all these things. That was a very, very detailed question. Solving a question like this. So those who have missed this, they need to cover this up. Lecture 15 was also of the same type. Some logic related with a graphical solution of equation, some more past paper questions, and things like that. Then in this thing, no, this is for today. This is my A-level stuff. And where is it? Over here. 16, 17, 18, 19. Lecture 16, more sketches. And then this is quadratic, and then the quadratic sketch, and then the translation up and down, minus x squared plus 1, minus x squared minus 2. Then it's 2x squared. This we talked about earlier. We further talked about it at one point. Completing square method, very, very necessary. Getting this thing in the form ax minus h whole square plus k. A is the coefficient of x squared. If it's positive, that's the shape. If it's negative, that's the shape. H comma k is the coordinate of the turning point. How do we convert it? And the line x is equals to h. That's a line of symmetry. What we do is that we make sure the coefficient of x squared is 1. The x term as it is. Push the constant to the side. First add, then subtract square of half the coefficient of x. Rewrite the first 3 terms as a perfect square. Basically, this is an expansion of this. So we compress it. We say, let's take x outside. Let's take 2 outside. Middle sign is positive. That is x plus 2 whole square. Go over this. Y is equals to, x is equals to minus 2. That's a line of symmetry. More examples, more examples. The factorized form, everything related to quadratics is a must. We just factorize it, we equate it to 0, we get the roots of the equation. Roots means x-intercept. Roots mean solution of equation, where the graph cuts the x-axis, y coordinate is 0. And then in lecture 17, we again went to power functions. Now this is the horizontal asymptote. It gets very close to this, but does not actually touch it. And then I think this lecture was kind of short, maybe because of some technical issues. So that's a very short class. Lecture 18, that was last time. We talked about cubic functions, negative x cube. And then again, we start with the top right, we go till bottom left. We talked about translation up or down. We talked about 2x cube, that is more stretching. K is greater than 1, more steeper towards y-axis. K lies between 0 and 1, more flatter towards x-axis. K into minus x cube. K is still positive, but because of the minus sign, so we draw this original one and then we make it steeper. We draw this purple original one and then we make it flatter. Something like this, there is x in all of them, take the x common out. That means one of the root will be x is equals to 0. It has to pass through the origin. And we just factorize it and get the answer. For example, like this, take x common, factorize it. So one of the root is x is equals to 0, the other two roots are 2 and 3. That's how it goes. We start with the top right, goes till bottom left. Over here, coefficient of x cube is negative, so we start with the top left, go till the bottom right. And lecture 19 is what you are seeing right now, that is about the reciprocal. So this is all good, all done. And let's start with the past paper problems. So let's look at this question. It says write x squared plus 10x plus 6 in this form, x plus a whole squared plus b. So what I'll do is that I'll write, first of all, let me grab this thing. This is the first x squared, the coefficient of x squared is 1. If it's not 1, we will take common. So therefore, this is x squared plus 10x plus bracket square minus bracket square plus 6. What goes inside the bracket? Half the coefficient of x. You just write a 5 over here. You just write a 5 over here. So why do we do this? That's a good question. That is, we are not going over the logic. That's the first answer. I mean, that is an answer because if I explain everything in detail over here, then it might be confusing to some people. So still, let me give you the idea. If I have x plus 5 whole square, that is x square plus 10x plus 25. This x square is basically square of x. This 25 is basically square of 5. So basically, we just pick these two and we rewrite it back like this. That's the whole logic. The next logic is, whatever is the constant term in such an expression, it's always square of half coefficient of x. That's the main thing. So half of 10 is 5, 5 square, that will make it a perfect square algebraic expression. Perfect square algebraic expression. So that is of either x plus 1 whole square, that is x square plus 2x plus 1, and I'll just let you double check it. X minus 3 whole square, that is x square minus 6x plus 9. Now over here, look at the coefficient of x, that is 2. Half of 2 is 1. 1 square is 1. Half of negative 6 is negative 3. Negative 3 square is 9. So that is the hard and fast rule for a perfect square algebraic expression. So now over here, we have 10. We half that and we get 5. But whatever we add, we have to subtract it. And it is explained in that lecture, so I'm just going over that. First add, then subtract square of half the coefficient of x. Rewrite the first three terms as a perfect square. How will we write it? We will write this thing as x plus 5 whole square. Simplify the rest. So if we simplify the rest, what do we get? That is negative 25 plus 6. That is negative 19. And that is the answer for this particular part. All good, all clear? That's how we write it. Now the second part. Use your answer to part A to solve this equation. But wait a minute. Some people, they ask this question. Let me answer that question also. That is there an alternative way of doing it? The answer is yes, there is an alternative way. That alternative way is called comparing coefficient. That is x plus a whole square plus b expanded. That is x square plus 2ax plus a square plus b. And now compare it with x square plus 10x plus 6. So now over here, this b, this 2a, that's the coefficient of x, this 10 is the coefficient of x. So 2a is equals to 10, therefore a comes out to be 5. And then compare these two, a square plus b equals to 6. So a square plus b is equals to 6, 5 square plus b is equals to 6, therefore b is negative 19. That's how you get it. That is another way. But the process is also that knowledge should be needed. So we have to write it in this form. So we will write x plus 5 whole square minus 19. So this is an application of completed square format. So this is completed square form. The next part, use your answer to part A to solve this question. Give your answer in the form P root Q. Now we are not solving this basic thing. This is a paper 1 question. So this is a paper 1 question. So now it's asking us to use that part. So therefore, what do we have? We have x plus 5 whole square minus 19. That is this thing right over here, which we got this in this format. Okay, why is it not working? Okay, that is this thing. And equate it to 0. So when we equate it to 0, we have x plus 5 whole square is equals to 19. X plus 5 is equals to plus minus square root of 19. And therefore, x is equals to minus 5 plus minus square root of 19. So therefore, the answer is in this form. X is equals to minus 5 plus minus square root of 19. This is of the format P plus minus Q, plus minus root Q. So what is P? If they would have asked me separately, I'll say P is negative 5 and Q is 19. Now let me just go over the WhatsApp if someone has asked this question. Why did you broke 10 and not 6? Because that's a rule of it. Maybe you have skipped that class, so you have to see the whole lecture. You break the 10 part. You don't break the 6, you break the 10 part. You keep this thing on the side and you add and subtract. That's the rule. First add, then subtract square of half the coefficient of x. So once you read that lecture, you will be all set, all clear. Another one of this type, and this time let me pause the recording. I'll wait for you people to try this thing out. So now let's look at this question. This question says x square minus 6x minus 7. We have to write it in the completed square form. So let me write it. X square minus 6x plus bracket square minus bracket square minus 7. What goes inside the bracket? Half the coefficient of x, which is negative 3, negative 3. Rewrite the first 3 terms as a perfect square. So we take the x out of here. We take the 3 out of here. Since this 3 is negative, therefore x minus 3 whole square. Double check. If I expand this is x square minus 6x plus 9. This is x square minus 6x plus 9. Simplify the rest. That is negative 9, negative 7, which is negative 16. And you get this thing. So now this thing is done. Find the value of A and the value of B. Now you have to compare coefficient and say that x plus A whole square plus B, therefore A is -3 and B is -16. So you would say -3 is plus A is -3, B is -16, you just write it like this. Hence solve this equation. This is just like this thing, except the answer might not be in the radical form. The square roots are called radical. So therefore we will write x minus 3 whole square minus 16 is equals to 0, because this thing right over here, that is exactly this thing which is over here. So all we do is that we take this thing, we equate it to 0. So x minus 3 whole square is equal to 16. X minus 3 is plus minus 4. Write it properly. Okay. This is plus minus 4. Therefore, x is equals to 3 plus minus 4. So you end up with two answers. Therefore, x is equals to 3 minus 4, which is -1. And x is equals to 3 plus 4, which is 7. So these are the two answers. Now, if someone did factorization directly, they will receive no marks. They will receive 0 mark. Why? Because it uses the word hence. That means you have to link it with the original one. So this part is linked with this part. So it's a hard and fast rule. The next one. It says this is a sketch of the graph y is equals to x square plus ax plus b. Find the value of a and b. A very nice question. Now this is related to the factorized form of the quadratic equation. Y is equals to x minus p, x minus q. And there is an a over here. Now, it says that the coefficient of x square is 1. This a has nothing to do with this. So let me just write something else so that it doesn't mix up. So let me write 1 over here directly. The coefficient of x square, x into 1. So therefore, this value is 1. What is P and Q? P and Q are the roots of the equation. So one of the root is 2, the other root is 5. So therefore the equation is y is equals to 1 and this is x minus 2, x minus 5. All you have to do is to expand it, which is x square minus 2x minus 5x, which is -7x plus 10, and then compare it with this one. So a is the coefficient of x is -7, so a is -7. The constant term is b, the constant term is 10, so therefore b comes out to be 10. Make a habit of writing it. So this is -7, this is plus 10. So that's how this particular question is done. And I think that's all about the sketching that needs to be done. So let me end it over here. This is lecture number 19. And this is lecture number 19 of algebra. And the sketching part is all done and dusted. That means in the upcoming class, what will we start? So we have this thing that is something about number pattern. And then we have the basic idea of functions. Function, composite function, there is something new in the syllabus also. So function, the composite function, new composite part is also there. And let's look at the syllabus. I think if the syllabus thing is right over here, yeah, there it is. So now it's a good idea that recap whatever we have done so far. So when we talk about algebra, what we see is that, I think there's a slide lag today. I think I'm just moving my hand. It's all good now. Okay. So introduction to algebra, that's all done. Letters can be used to represent generalized numbers, substitute numbers into expression formulas, algebraic manipulation, expression, simplify, expand, factorize things of this type. And this thing is just taking x common out, complete the square, that's done. Fractions, algebraic, that's done. Simplify, rationalize, it's all in the initial lectures. Not yet. Indices, not yet. Now this indices is linked with this indices of numbers. Let me just show it to you. Estimation, standard form, indices 1. So indices 1 is part of numbers and indices 2 is part of algebra. So in order to do indices 2, we will also do indices 1, which is part of numbers, and we can do this thing in one class. So this is important that we need to do. Equations, construct expression, equation, formula, solve linear equation, fractional equations with numerical and linear algebraic denominators. These are all the examples. This is all done. Solve simultaneous equation in two unknowns, solve quadratic equations, completing the square, use of the quadratic formula, change the subject, all done. Inequality, that is not yet done. Okay? So this is inequality is not yet. And let me write it over there so that I have a record of what needs to be done and what's not. So inequalities, that needs to be done. This is simple. And then we have the graphical thing. So that thing is not done. And what else is there? So everything related to that. Sequences, this is number pattern. So sequences, number pattern, not yet. And then a proportion, it's all done. Graphs in practical situation, no, not complete, not yet. Graphs in practical situation is not yet done. So let me write over here, graphs in practical situation. It could be currency exchange and things like that. It could also be the distance traveled. So therefore, let me write over here, kinematics. But kinematics is related with coordinate geometry. It's related with algebra. And let me write indices also over here. That is algebra and that is numbers. And then graphs of functions. This is all done. Sketching graphs, it's all done. Functions, not yet, already written over there. This is the new thing, form composite function. It was not there before in the syllabus, now they have added it. And that's about it. So what we will do is that we will do coordinate geometry first, and then we will do kinematics, because you need the logic over there. So basically over here, now the order in which we should go is that let's do functions first. So I think that should be first. And then let's do indices second. Algebra plus numbers, we will do both of them. And the third one should be third one should be inequalities. The third one is inequalities. The fourth one is number pattern. And then coordinate geometry, kinematics, algebra, this should be the fifth one. And graphs in practical situation could fall under that category, after that or before that. So this is the order in which we'll be going now. So that's all done. We are finally done with sketching, and let's wait for the next class for more info.